Now, Jeremy Janane, President of Urban Milwaukee, will introduce our speaker for the day.
Good morning. I was a bit confused when Aaron and Mary asked me to introduce Tim Gokhman, because a couple months ago I introduced someone and they had to leave the country, but I hear Luxembourg is a very lovely place. So our speaker today is Tim Gokhman. If you don't know the Gokhman family and Newland Enterprises, you're certainly familiar with their work. They've, in the past 20, I think we're probably closing in on 30 years now, have utterly transformed many corridors in Milwaukee, particularly on the east side in the downtown area. They're now expanding out into Walker's Point, into Bayview, into many other areas. I have the privilege, it's work, at Urban Milwaukee of touring many new buildings when they go up. Not always are they so exciting, but I know when I'm getting a tour from Tim, I'm always going to learn something. As a journalist, you not only have to be a good communicator, but you rely on your people you're talking to be good communicators themselves. Tim's always got ideas both about what he's doing and what the future holds. I think we're going to hear a lot about that today, but where in recent buildings, I'm not even talking about Ascent, I've learned about things like biophilia. I've conducted an interview while on a swing in the lobby of an apartment building. That's somehow a thing that they've engineered into a building. So Newland's always up to interesting things. I think we're all going to learn something today. I can't tell you exactly what it is, but without further ado, Tim Gokhman.
Thank you, Jeremy. That was a very generous introduction. All right, so good, technology is working. My name is Tim Gokhman. I'm the managing director of Newland Enterprises. As has been referenced earlier, one of the founders of Newland Enterprises is sitting right there, Boris Gokhman, my father, who brought me to this country in 1990 when I was 10 years old. That's a separate story. Today we're gonna talk about Ascent, but I'm gonna give you a quick overview of Newland and some of its work if you're not familiar with it. So I'll dive right in. I'll try to get through this presentation very quickly and leave time for Q&A at the end. Okay, so is this echoey or is it me? Good, all right. Newland's been around for a little while. You can see some of the stats and information in the background. And one of the things that I love about this company is how diverse its offerings are, how different, not just the products, but the type of projects that we do. So let's take a look at some of the more memorable ones we've done. If you're not familiar with Black Cat Alley, this is between Prospect and Farwell and Kenilworth and Ivanhoe on the east side behind the Oriental Theater, which we also happen to own. And this used to be a very dilapidated space. The image on the left is actually after the alley was repaved. And really neat civic project, turning a completely obsolete space into something that is active and joyful, that brings people together, whether it be for photo shoots for graduations or even Coles and Harley, et cetera, have used it for photo shoots. Of course, we're primarily known as a real estate developer, but Newland's history has always been innovation, whether it be selecting geography. Pretty much every new neighborhood that you can think of that has become popular in the last couple of decades, we're typically the first with market rate housing in there. But then also building technology. So for example, Rhythm here did a couple of things. Rhythm got us on the path to radiant hydronic heating. We'll touch on that a little bit later. They were the city's first micro units with smart furniture. And this building also used light gauge steel construction, which we brought to the multifamily market in Southeast Wisconsin and continue to use a lot. This is the entrance to Bayview. And that is what it used to look like when Hamburger Mary's was there. This is what it looks like now. That's a 140-unit project with 16,000 square feet of retail on the ground floor. The project combined 5 different parcels working with the city. We actually closed down a street and converted it to a pedestrian plaza, which is heated underneath. And then the project is actually serving as a catalyst for the eventual makeover of Zillman Park. So we've dipped our toe into private-public as well. Another great project in infill development. This is on the east side. This is called Urbanite. This is a 13-story post-tension concrete building with 153 apartments and about 6,000 square feet of commercial space. What those slides show is that, number one, we've been innovating for a long time. Number two, we are what we call construction technology agnostic. We will build stick frame, we will build townhomes, we will build light gauge steel, we will build post-tension concrete, and now we're building with mass timber. So why did we decide to build a luxury high-rise out of mass timber? Well, first and foremost, we wanted to build a luxury high-rise. Prior to the construction of 777, we have been advocating for the development of a super amenitized building downtown Milwaukee, and we're having a very difficult time getting traction because most people locally didn't think that there was demand for such a product, which of course was absurd because we would be the only city in the country that would have high-end condominiums like Kilbourn Ave University Club, but not high-end apartments. Nonetheless, it wasn't until 777 opened up the marketplace for us that this project proceeded, and we wanted to do something visually different. And so in 2017, I saw a conceptual study done by the internationally renowned firm of Perkins & Will, an architectural firm, and Thornton Tomasetti, a structural engineering firm. And their concept was an 80-story mass timber building in Chicago. Just a concept, not really feasible, but in 2017, it opened up our imagination to the possibility of building a high-rise out of wood. And what's cool about it is not just that you can build it out of wood, but unlike concrete and steel, if properly designed, the mass timber inside can be left exposed, meaning that the infrastructure of the building is now all of a sudden visible. Happens to be that in Milwaukee, we already know that this is possible because if you go to the Third Ward or even Walker's Point, we have old heavy timber buildings, right? You walk in, you see the exposed columns, the exposed beams, and we naturally gravitate towards those buildings. Now, at the time that we decided to do this building, we didn't know what the word for it was. Jeremy mentioned it before. It's called biophilia. It is the impact of natural elements within the built environment on humans. And because we know that we gravitate towards these types of buildings, the impact is good. So that was our initial driver. We wanted to create a building that was aesthetically superior to currently available construction methods. What we ended up learning, and we took a 2.5-year journey, and I'll briefly summarize it, but what we ended up learning is that mass timber is much, much more than just superior aesthetics and biophilic benefits. In almost each and every respect, it is my strong opinion that mass timber should be the dominant construction technology in the future when it comes to buildings that are for multifamily residential, let's say 8 to 25 or even 30 stories. And even buildings below 8 stories where you're using concrete, for example, an office building, probably makes sense to use mass timber. So this is the aesthetic that really drove us. You can see the exposed wood elements and the warmth that it brings to the built environment. This is a rendering of one of the apartments in the building. This is actually a rendering of our 25th floor. So the entire top floor at Ascent is an amenity floor. And we'll touch on that a little bit later as well. But again, what started as a quest to deliver a superior aesthetic really led us to understand that the beauty of mass timber, and I compare this a lot, as you can see, to Tesla. The beauty of mass timber is that there's very little compromise in terms of bringing a new technology to the market. And usually the challenge with innovation and new technologies is that you have to get over this hurdle of, well, why are we going to use this new thing? we already have this existing thing that works fairly well. So why take the risk and figure something new out? The reason why Tesla did so incredibly well is that there were no compromises, unlike its predecessors, let's say the Chevy Bolt, the Nissan Leaf, etc. There is no compromise in aesthetics. There's no compromise in performance. There's no compromise in price. That's why Tesla's done what it's done and has moved the entire industry a decade forward. Well, mass timber does the same thing. So the only challenge is, of course, figuring it out, because it's never been done in Milwaukee at height. And prior to Ascent, the tallest mass timber building in the United States was 8 stories. There was an 18-story in Vancouver. There were multiple 20-plus story buildings in Europe. But in the United States, we really didn't have the knowledge. And so in 2018, when we unveiled the project, we were invited to Dubai. We went, we presented. As my dad will remind me, initially I had trepidation about going to Dubai, and he insisted. And so we went, and that was a good idea. The reason why it was a good idea is because we met a number of these people who are now part of the project team that really brought expertise and experience in developing and designing and engineering tall timber. And so that's how we assembled that team. This is a brief overview of the timeline. I would be remiss not to mention how fortunate we are to be in Milwaukee, because in the city of Milwaukee, serendipity played a part. We had a fire department that was already familiar with mass timber, and we had a city administration that was partially familiar, but also very open-minded to the science behind the engineering of mass timber that allowed us to do this. It is far from a foregone conclusion that this would be feasible anywhere in the United States. In fact, we believe that there's only a handful of cities where this would have been impossible. Milwaukee's one of them. So a little bit on the engineering. Ascent is actually a mass timber hybrid. On the very left, you see the piles that are driven into the ground, because mass timber is about 60% lighter than concrete. The number of piles and the depth of the piles are greatly reduced, almost by half, versus what it would be with a typical concrete building. And then you can see the podium and the shafts extruding upwards are concrete. The podium is concrete because that's where our cars are, and our swimming pool sits on top of it. The shafts are concrete because A, they handle the lateral load, and B, the fire department wanted an independent structure for fire safety during construction. But the rest of the building is timber. And I will back up and quickly explain what mass timber is. Mass timber is a catch-all phrase. It has under its umbrella multiple technologies. There are 2 different technologies in Ascent. There is glue laminated beams. So you're taking regular pieces of dimensional lumber and you're gluing them together. Glue lam is very similar to LVL, which has been around for decades. And then the newer technology are the decks that are spanning and sitting on top of the columns, the floor deck. That's called CLT, cross-laminated timber. And unlike glue lam, right, wood is grain, so it's running in one direction. When you take those grains and you start sandwiching them perpendicular to each other at 90-degree turns, it's like taking a dollar bill, folding it 4 times and trying to tear it. You can't. So it introduces a very different level of strength and dimensional stability. So that's what the decking is. That's the pioneering product that is allowing mass timber buildings to go taller. Now, the trick in the United States is no building has ever gone through the fire test necessary. No mass timber building has gone through the fire test necessary to prove that the technology will perform as well as a concrete or steel building, meaning it'll meet the necessary fire ratings. For us, it was a 3-hour vertical and 2-hour horizontal fire test. And so we are the recipient of a grant from the U.S. Forest Service. We did 14 fire tests with the forest laboratories. Some were done nearby in Madison, which is great, one of the most advanced forest labs in the country. The rest were done in Texas. Needless to say, they passed. But neat picture on the left. Our architect took that shot. That's inside the furnace. And then on the right, you can see the columns. So This is the science behind why the mass timber can be exposed. What's left is what you need for the structural integrity. What is charred on the outside is called the sacrificial layer. So even if the sprinkling system and the backup for it fail, this building can survive for at least 3 hours. And the benefit of mass timber is that not only is it going to survive for 3 hours, and we know this, right? We know this because we have old heavy timber buildings in Milwaukee that have gone through 5-alarm fires. The Button Block building, which is now Homewood Suites on Water and Clybourne. Thank you, Jeremy. That did not have a sprinkling system, went through a 5-alarm fire, still standing. So that was the science behind it. Really, really neat. The fire department actually confirmed that unlike steel, because mass timber chars, if you've ever started a campfire, you know how big logs don't burn all the way through. Not only does it char, but it does so at a very linear rate. Whereas, for example, with steel, once you get over 1100 degrees Fahrenheit, at some point it will buckle because steel is expanding with heat and it's losing its structural integrity. And the problem is you don't know when or how, but it will fail. With mass timber, it's much more linear, much more predictable. So that was the fire safety and the engineering. And then the really neat thing was the digital engineering of the building. So the building was actually designed down to the light switches, down to the screws, digitally first. Then those digital shop drawings were sent to Austria, where the mass timber was manufactured by CNC machines. And as the building is built, the digital model is getting updated. So you know down to pretty much the millimeter where everything is in the building. This technology is also relatively new. The computing and the processing speeds of the software needed for this hasn't been available, I don't know, 2 decades ago, 15 years ago. This is a relatively recent development. And this is what it looks like. So you can see the columns, you can see the beams, it's all wood. And then these holes that you see, those are penetrations that are cored in the factory, in Austria, being shipped to the United States, being assembled in place with the precision of 1/16 of an inch. Vast difference from concrete and steel, which is incredibly imprecise. So the key here is to get that previous digital model right and to not forget any penetration. So it takes a ton of coordination up front with all of the mechanical engineers, right? The plumbing, the fire safety, the electrical. Everybody has to submit their drawings ahead of time. Everybody has to decide everything ahead of time. You have to do conflict checks so that pipes aren't hitting each other. And then you get all of those. That's the building under construction. For those of you that have driven by, you know that the building is now topped out, but that's a neat picture through the middle of construction and as the building approaches topping out. And this is going back to the original reason why we did it. That's a living room. So you can see that some of it is wrapped in drywall, but the ceiling is exposed. The beams and the columns are exposed. And it creates this really neat, warm aesthetic. Now, the amenities I don't have pictures of yet, but the building is not innovative just because it's using mass timber. The number of amenities it has per unit per square foot are unmatched. So on the 7th floor, on top of that concrete deck, we have a fitness center. It's overlooking the lake. It's overlooking the city. It has exposed wood elements in it. Imagine working out in that. Facing on the southwest corner in a 2-story volume, we have a swimming pool. So on the 7th floor, it also has phenomenal views. Now notice it's inside, but can you see my mouse move? No. You can see it in the facing south towards downtown, the 2 rightmost sections. Those windows collapse. It's a sliding glass door, as does the rightmost or the northmost on the west side section. So we really get this feeling of indoor-outdoor. This was a design that my dad and I thought up. We haven't seen this before, but we wanted to create a swimming pool that we could use year-round, but wouldn't have the feeling of just being indoors. So we got the best of both worlds. Really cool innovation there. And then really Ascent has pushed us to question, rethink all of the other elements. For example, the question that I asked of my design team is, for a residential building, should a lobby be a transactional space that you go in and out of, or should it be an extension of your living room? That type of thinking really changes how you design spaces and what they look like. So that's a lobby. Looks more like a living room. Here's our 25th floor. So the entire top floor of the building, because of this unique HVAC system that we have, is an amenity floor. So we've got 2 huge outdoor terraces, 2 clubhouses. There will be a private bar, which we will staff with a bartender on Thursday, Friday, and Saturday nights. That will be for, my dad's very happy about that. That will be for residents and their guests. We've got a golf simulator up there. We've got co-working spaces up there. There will be a rec room up there. So incredibly amenitized building. There will be an outdoor movie screen with a turf. So yes, very, very, very neat building. And the HVAC system, I quickly touched on this before, but Ascent not only deals with, through mass timber, what we call embodied carbon, so the energy and the carbon footprint in building something, but its operational carbon footprint is also incredibly low. Part of it is, of course, advances in appliances and Energy Star LED fixtures, etc. But Ascent will also be LEED Silver certified. And this is, if you really get into LEED, this is version 4, which is the most stringent version of LEED. Part of it is the HVAC system. Our heat is in floors. So instead of a furnace, we've got boilers on the ground floor that are pumping water up through tubes that are embedded in the lightweight concrete that sits on top of the concrete deck. So that's the primary source of heat in the building. Very nice amenity to have in a climate like ours as well. Never mind the improvement in air quality, because instead of drying out air from the outside and pumping it in, you're just conditioning the air inside. So the humidity is higher. We have less ductwork, so less space for allergens, dust, etc. It's just a better environment altogether. And in the grand scheme of things, to kind of summarize why I think mass timber is really the way of the future, you can see all of the additional points that mass timber brings. So C.D. Smith will confirm they used about 1/4 of the labor force in erecting the building versus what it would be with post-tension concrete. A benefit on so many levels, because it's less people working for a smaller amount of time with a more controlled technology is just by definition more safe. Never mind the labor shortages and everything else. And again, the reason why I make the comparison to Tesla, and the reason why I think mass timber is already an unstoppable force, is because of the mainstream adoption that you already see happening. So the neatest one to me was Walmart, which is building its entire campus, 1.1 million square feet, out of mass timber. In fact, they brought a Canadian manufacturer called Structure Lam to an adjacent town. And so now there's a new factory being built to supply this, but then also subsequent projects. So really, really neat developments for mass timber throughout the world. And then we've gotten a lot of press for this. We've been featured in the New York Times, in the Washington Post, in the Chicago Tribune. We were featured on NPR. We had an episode produced by PBS for PBS NewsHour. And in a couple of months, it's a major cable channel, but we did a documentary with them. It's almost an hour long. And in the last 2.5 years, I learned a lot about forest management and why it makes sense to use trees and why it's actually better for the environment to cut them down and regrow them and so on. And I've always known that concrete was a necessary but very imprecise and kind of brute force technology. What I didn't know that I learned through this documentary is that throughout the world, the type of sand that's used to make concrete is finite. You can't go to the Sahara Desert and get that sand. It's too fine. And so apparently, and I was so surprised to hear this that I had to do my own research, but it's true. There are mafia rings that used forced labor and illegal mining practices and the dredging of rivers to get this sand for concrete because it is finite. And while we can say that, well, in the United States, our concrete manufacturers don't use this sand. It's true, they don't. But they benefit from it because it lowers the price of this sand worldwide. And so I don't think mass timber can replace concrete. We still need it for footings and foundations. No one's found a different technology. But I do think that specifically the real estate industry has to catch up to pretty much every other industry and innovate and lower its carbon footprint, lower its weight. I mean, there are cities that are literally sinking under the weight of their concrete buildings. It's a fact. Because structural engineers only calculate the support needed for the building. They've never thought about the entire city grid and the amount of pressure that these heavy concrete buildings are exerting on it. So for a ton of reasons, we are excited about this project, what it means for Milwaukee, what it means to have Milwaukee in the international spotlight, and what it means for the future of the construction industry. With that, if anybody has questions, I'll take them. Thank you. We've got one question here, one question there. So the question is, what's the parking situation because street parking is difficult? So first of all, Ascent has 259 apartments. It has 330 parking spaces. So our residents are accommodated. We've got close to 1,600 apartments in the city of Milwaukee, so we understand parking ratios really, really well, and they differ significantly depending on the type of product. But we believe that the residents are taken care of. In terms of guests, I have a very unbending view on parking, especially when it comes to street parking. Cities can choose to be either one or the other. Either they can be built around people or they can be built around cars. You can't have it both ways. You have to choose. And I always say it this way. Think about your favorite destinations to travel to. What cities do you love most to go to? Are they the cities with drive-throughs and ample street parking, or are they the cities with walkable sidewalks and restaurants and cafes and life and art and so on? It's usually the latter. It's usually the New Yorks and Parises and Amsterdams, etc. And so Milwaukee has to make a choice. Either we abandon our love affair with the need to park a half a block away or right in front of the door, and we start relying more so on mass transit and Uber and etc. Or we stay where we are, which is Milwaukee is one of 4 metros in the United States, major metros, that managed to lose population in the last decade. 4. Every other city has made investments into bike infrastructure, pedestrian-friendly infrastructure, mass transit. So Milwaukee has to decide. It has a lot of great things going for it. It's easy to live here. The cost of living is incredible. We have more Fortune 500 companies per capita than almost every other city in the United States. We have a great water technology scene. We have a great restaurant scene. But I think that for visitors of the building, we have to start thinking about either it's okay to walk a couple of blocks, or maybe we take the hop, or maybe we take an Uber. But it's got to be one or the other. I'm clearly a proponent of the latter. Yes? So two-part question. One is, you built a premium building with premium amenities and premium costs. How much of that cost is related to the next technology? You see that changing over time. And then secondly, you build another one and you start parking it for less Sure. Excellent questions. Thank you. So the first question is, what cost premium, correct me if I'm wrong, what cost premium is there with mass timber? And the second component is, are you going to build more mass timber buildings and can the cost come down? Fair? Okay. So cost premium with mass timber, super complicated question. The cost of the mass timber structure is relatively consistent. Whether we chose our manufacturer in Austria because they have the longest track record and they were actually more price competitive even with the shipping costs. But that's changing. There are Canadian manufacturers, there are now American manufacturers. Eventually, we'll catch up locally and we have more than enough supply. So, fun fact, the amount of mass timber used in Ascent is replaced by natural growth in North American forests, meaning just, right, no replanting, just natural growth in 22, 23 minutes. More than enough supply. But the cost of mass timber for me is always in comparison to concrete. The cost of concrete in Milwaukee is relatively low. It's relatively affordable to build in Milwaukee. So in order to truly scientifically know what the cost comparison is, you'd have to design the building in both versions down to the structural engineering and price it out. Roughly speaking, with C.D. Smith, with my dad's experience, we know what the construction costs are, and we believe it comes out par or maybe a slight premium. There are big premiums in insurance, insuring tall timber, not because of fire, but just honestly, lack of data points is complicated. That's going to get better. AXA's already moved on this. There's been improvement there. And frankly, there's some inefficiency. I mean, we're figuring out engineering questions that just have never been asked before of mass timber that have been done thousands of times in concrete. It's not whether it can be done or not, it's going to be done economically. But in the grand scheme of things, I think it comes out par in Milwaukee. That means that in a market like, okay, so Milwaukee concrete, post-tension concrete, let's say roughly 37, 38 bucks a foot. You go to Cleveland, it's 55. You go to New York, it's 90. So mass timber becomes really, really competitive as you move into these other markets where concrete is more expensive. Our thought process on it is if it can be done in this market, it can be done anywhere in the United States. There's no economical excuse for not doing this. Do we plan to build more? Yes, absolutely. We are looking at other markets. We would build another one here, given the right opportunity. But in terms of price coming down, it'll get more and more efficient against concrete and steel. It'll never beat stick frame, right? So if we start getting into affordable housing, like the question's asked, can mass timber solve affordable housing? No, it can't. It can only solve making a building built out of concrete or steel more efficient. But it'll never come down to the cost per square foot of a stick frame building, horizontal build. But biophilia, as Jeremy noted, you can go to our stick frame built Kinetic in Bayview. It's a 6-story building. It's a classic 4/2. And we've put in swings, we've put in plants, we've put in elements that make the space joyful. So those are two different things. Mass timber, of course, helps significantly more because of the exposed wood, but you can achieve it in other ways. Yes, in the back. Yep. So also a really great question. The question's about the glass, how much of it is on the building, and how it relates to the environment around us. The building's actually about 50% glass. So there's spandrel, there are panels, but yes, we actually go through. We have a envelope consultant on this building. That's the first time we've used an envelope consultant. And we go through energy modeling to optimize where the glass is and how it reacts. But yes, you have to have high quality glass, and you have to balance the energy load of the building between views and energy efficiency. In terms of concern for birds. The residential buildings, not as much as when you start using curved glass and how it reflects. So here we don't have a concern about it. There was, I apologize, I don't know in what order the hands came up. I'll let you negotiate for it. Yes, the question is, there's a perceived increase in speed and efficiency on this site versus others. Yes, it's absolutely true. The amount of time spent designing the building up front is much, much greater because of all that coordination, but the amount of time spent in the field is much, much less. So the amount of time the piles were being driven was cut in about half. Think about the benefit to the neighbors that you're listening to that pounding for 50% less time. And the speed of construction, our construction timetable was about 22 months. In PT, we think it would have been roughly 26. So we think that's a pretty significant savings, right? We're talking almost 20%. So yes, much, much faster. A lot of it has to do with, right, once the glass goes on and everything else, that's the same time. It's really the frame that's going up. And the advantage of mass timber is that you're getting these pre-manufactured panels that are just being screwed in place. The building is literally, it's Lincoln logs. It's screwed in place. And so it's not only faster, but it's also quieter. It's cleaner. C.D. Smith told us that one of their foremen goes home and he's used to working in concrete. So now he goes home and he's not as tired. He's clean. His wife doesn't believe that he goes to work. I see that as a benefit, but they have to work that out. Yes. The question is, are the design skills for a building like this different, and do we have them in the US because it's going to Austria? So a complex question. Locally, we had to learn on the job and in the design process, but that's why we built the team that we did. Had we only tried to do this with local knowledge, it would have been a failure. So, our fire safety engineer is Australian. There's another contractor on the job, used to be Swinnerton, Mass Timber, now it's a separate company called Timber Lab. They're from Portland. It's a company that does mass timber and nothing but mass timber. Thornton Tomasetti is a worldwide known structural engineer, has done structural engineering on some of the world's tallest buildings. But the principal, John Peranto, who's in Chicago but spends time in Milwaukee, is now a somewhat local guy. And they have a structural engineer in their office that worked on the Brock Commons building in Vancouver. So the knowledge is building in the United States. The Austrians were more chosen for their production expertise and their efficiency in production. The neat thing about KLH and Weehag in Austria, specifically KLH, the manufacturer of the cross-laminated timber, they have their own forest. So they're not buying lumber on the market, they're going out, and the technology is amazing. They have drones that map out the forest, and so they're picking where they're going to cut the trees, and they're going in and cutting it down. It's incredible. So, but the United States is getting there. The work that the Forest Service is doing is really, really cool. Yes? Yep. The question is that tall buildings tend to sway and flex. And so can I talk about the structural differences between a mass timber building and a concrete or steel building? The answer is no, I can't. I have no idea. That's what structural engineers are for. What I can tell you is this. So first of all, right, if you remember, there's the concrete pours, the staircase and the elevator shaft. So those are helping handle the lateral force. If those cores were built out of mass timber, we'd need to have more exterior bracing to handle the lateral force. on the set of plans inside of C.D. Smith's construction trailer, and the plans are this big. There's one page that's just numbers. There's got to be over 1,000 of them, and the structural engineers have calculations for how the building moves. Each component of the building, the concrete in the building, the steel connectors in the building, and the mass timber, they're all moving at different rates. And they have all of those calculations projected through time, and then as the building is being built, they're field verifying every single piece that's being installed, etc. So what I can tell you about mass timber is that it's not regular 2x4. It's not expanding and contracting the same way that typical wood does. If any of you have engineered floors, wood floors in your home, it's the same technology. The subfloor underneath the top is that same 90-degree technology. It's that same, really, it's cross-laminated plywood. And it is incredibly stable. It is incredibly, incredibly stable. So much so that one of the biggest proponents and one of the biggest early R&D sources is the Department of Defense. The Department of Defense has been testing mass timber for a long time because it is incredibly blast resistant. It also does really well in seismic conditions. So that flex, its ability to handle force and flex, is actually much better than its counterparts. It just needs to be coupled with other technologies where it needs to span or where it needs to have a footing or where it needs to have a connector. Yes?
So I live in Yankee Hill, building right next to it. I agree that watching it go up and even living in the neighborhood, parking, I've been amazed at how few actually. Like, as a neighbor, I can say, nobody's working on this building. Like, who's doing it? So it's interesting to know. I also agree with you that I think the way of Milwaukee and downtown is always very downtown, and in that location, don't have to take a car. So I do think that we need to look at that as a city. But one of my questions is, like, who is your target demographic? One of the things I've noticed being downtown, I've only been living here about 6 months. I came from the Florida area. But, with a lot of people working remotely, still working remotely, not knowing when they're going to come back, seeing a lot of things downtown that are still not opening up.
Yep.
There's a lot of stuff that's happening or not happening. How is that going to impact?
Yep. So the question is, and thank you for the kind words on the construction. I mean, it's neat, right? It's neat to not have a line down the blocks of the concrete trucks with their spinning barrels. But the question is, what's the target demographic, and how do the events of the last 24 months translate into this building's occupancy? So the cool thing about Ascent is that it's not a cookie cutter high rise, especially when you wait till the end. Architects don't know how to design apartment buildings. Architects know how to design buildings. We don't know how to design buildings, but we know how to work with an architect to make it an apartment building. What I mean by that is, if you don't manage properties, and if you don't rent, and if you don't turn apartments over, how can you possibly know what people are looking for in their living space? You have to have that direct experience. So this building, we design buildings inside out. I think we're relatively unique in the local market for that. And what I mean by that is, we start with the floor plate and the floor plans and design the building around it. It's still form and function, but it's function first, then form, but not at the expense of. Does that make sense? So Ascent has 17 units per floor. We have 13, 14 different floor plans, starting from a 653 square foot one bedroom up to a almost 2,000 square foot 3-bedroom, 2.5 bath with a couple of penthouses that are a touch over that. So the target demographic is varied. It's not a kind of cookie cutter Chicago high rise, small 1-bedroom, 1,100 square foot 2-bedroom. We designed it with our average floor plan square footage is 20% bigger than a standard Milwaukee apartment. So we are anticipating people making the move downtown, but we're also anticipating young professionals living in this building. What I can tell you about the occupancy downtown, I remember when COVID started and people said this is the end of cities, no one's going to live in cities anymore, et cetera. We finished Q4, Newland as a company, finished Q4 of this past year with the highest occupancy we have ever had in our company's history. And so did the Milwaukee market. So people want to live in cities. We've made small tweaks, not in the floor plans, but in the common areas of the building to think about work from home. We've already pre-leased more than 10% of the building. Last year, we wouldn't even have started pre-leasing a building that early typically, but there's been so much demand. So far, I think that the trajectory is good for this building and frankly for downtown. Yes. What is the rent range? We start in the $1,600 per month range and up to over $8,000 per month. So pretty big range. Yes. Yes, definitely steering. The question is, can I clarify the comment on cutting down trees and why that's actually good? The assumption is that we're not talking about clear cutting. We're talking about selective cutting of trees and sustainable forestry. Yes, all of that. The neat thing that I learned is that more than 50% of U.S. forest land is privately owned. It's not owned by the federal government. And forests are either classified as working forests or non-working forests. And working forests are ones that are producing a good that can be monetized. If those working forests are not able to economically survive, they will be converted to something else. Agricultural, housing, what have you. And so creating the demand with mass timber, among other things, is actually critical to create the flow, the economic flow needed to support our forests. Our forests are actually vastly underfunded. That's why when the U.S. Forest talks about management of forest fires and thinning the forest, it takes money to do that. Number one. Number two, there is no better carbon sequestration technology than wood. And trees, when young, that's my warning to wrap up. Trees, when they're young, right, like any other living organism, when things are young, they grow a lot faster. Well, trees use carbon to grow, carbon, sunlight, water. And so taking younger trees, which is what mass timber technology does, we're using younger growth forests instead of old growth, and replanting them, you're actually sequestering the carbon faster. Now you've cut that tree down, you've stored that carbon, you put it into the building, it's now sitting there, that's it. And now you're growing new trees and you're sequestering more carbon. Compare that to concrete, which is incredibly energy intensive, never mind the sand issue, but incredibly energy intensive to get it, to make it, and then if the building comes to the end of its useful life, to destroy it. Versus with mass timber, you can just disassemble it. Or even if you knock it down, the carbon is still stored. So yes, the environmental benefits are myriad. Last one, or? Oh, thank you. Last one, or are we done? I can stick around.
I think you can stick around and answer questions.
Perfect. So I'll wrap it up. I will stick around if anybody has additional questions. Thank you so much for the warm welcome and for the opportunity to talk about this project.